Hello once again, and welcome to another day of me attempting to solve the 6 Nerdle puzzles. Let's see how we get on. Interesting. More reds for normal. Usually it seems when I start with this sum that I hardly get any information, but we've got quite a lot now. But the equals is not in the wrong place, which is interesting. It means we're either going to have a 1-digit result, which is potentially unlikely, given that we haven't got any subtraction. So maybe we're going to have a 3-digit result. 58 times 7 or something like that. What would that give us? Well, it would have to be 7 times 58. Otherwise the 8 is in the right place in the first row. That's 350, that's 406. That's too high because we need it to have a 3 in. 7 times 38 would then be too low because we'd need it to have a 5 in. So, what are we going to do about this? 57 times 8 doesn't have a 3 in it. Of course, it might be a multiplication with a completely different digit in that just happens to have a result of 350 something. 7 times 48 would be 336, so that doesn't have the 5 in, which is a shame because it's very plausible other than that. In fact, the other annoying thing is that if we're thinking it's multiplication, then whatever the units digit is isn't going to work, in the sense that no 2 of these digits multiplied together, the 3, 5, 7 and the 8, to give another digit from the same set, which means that that's going to be one of our unused digits. That's plausible. 350, 378. It's not even multiplication after all that, so we're going to have some division by the looks of it. 35 over 7 is 5. So we can't be plus 3 equals 8, because the 3 can't be here. It could be 3 plus 35 over 7, that fits. Got it in 3. I thought I was going absolutely nowhere there for a while. But in this game you can quickly make quite a lot of logical deductions once you start to get some digits in place and rule out others. It's not like Wordle where you can have the last 4 letters and not know what the first letter is. If you know everything apart from one thing in this, then you know the whole thing. Okay, so let's move the 8 and the minus around, so that's 1. Let's do times, oh no, 1 times anything is not going to be, let's do plus 9 then, equals 10, that gives us a completely new digits. Yeah, there's no plus, I didn't think there would be. It's going to be something times 8 probably, times 7, minus something. So, where's the 8 coming in? The options are 4, 6, 7 or 8, so it can't be 1 because we won't get a 2-digit result. It can't be 8 because that's not in that position. So if it was 4 times 7, that would be 28. We couldn't take away what, I don't think we can use the 1 and the 8 if it's 4 times 7. It's, oh, we just ruled out that, sorry. It's going to have to be, I think this might be forced for the top one. Oh. Should have realised. There's always one option you don't consider. So close. Right, and this bottom one, is it going to be something equals 8 or something equals 108 or some other 3-digit number? 1s, 2s, 6s and 8s is all that we can use, and it's only got division, okay. It's definitely going to be equals 8 then, isn't it? About 128 divided by 16, that's looking very likely, I think, except it doesn't have a 0 in. 120 divided by 15, it doesn't have a 5 in. Oh, so annoyingly close. So we need to use a 1 and a 2 and a 0. And it needs to be divisible by 8. And the only other digits it can use are 6. So, and it has to use the 1, the 0 and the 2 in some order. 108 divided by 16 doesn't use the 2 and doesn't make the correct sum anyway. 160 divided by 20, I think that works. It works so well that it is in fact correct. Right, what have we got here? So, 2-digit number divided by a 1-digit number plus a 1-digit number equals, okay, so 12 over 3 plus 5 equals 9. There we go, half a minute. Pretty pleased with that. That felt quite logical. Let's see if we can do the speed one anywhere near as fast. Right, 24 divided by 6 minus, oh, it can't be, let's do minus 4 equals 0, even though that's definitely not correct. It never seems to be a thing ending in 0, but that was actually a lot closer than I expected. So, minus 5 times 4, I think this has to be it, doesn't it? Yeah, because if there was no 0 and it had to be a 1-digit answer, I think that might have been false to that stage. But yeah, very happy with a 31-second solve. What should we do for this one today? Let's do 12 over 8. No. 16 over 8 makes a lot more sense. Very unlikely to be an answer of 1.5 in this puzzle. Wow, that's the least useful response I've ever had, I think. Oh, what do we want to do? 5 times 9. I don't like using the repeated 5s, but I don't think we can avoid it. Okay, so it is something times 5, probably 7 times 5. Yeah. Not too displeased with that. 3 guesses is never bad. But I am going to go back to the old tried and tested 1, 2, 3, 4 for this one. And I should not have bothered, although we've got the 1 and the 3, so that's not too bad. What are we thinking? 3 plus 7 equals 10, why not? Or it could be plus 8 or plus 9. Oh, and the bottom one as well. Bottom one has to be 5 plus 5 or 9 plus 1, I think. So there's going to be some repeated digits somewhere along the line. Let's try 3 plus 8 equals 11. Okay, and there is another 1, which means it's 9 plus 1, because it can't be 1 plus 9. That was why I tried that 3 plus 8, because I thought it might give us information on the bottom one even if it was wrong. I think this has to be correct. And it is. Solved it in 4. Thank you for watching the full set as always. Bye for today.